Today I wanted to talk to you about Bernoulli's principle. It's looking at your forces of flight. Many of you actually went beyond talking about the four forces of flight and actually talked about Bernoulli's principle. You didn't use the name, but you actually talked about it. Bernoulli's principle is the reason why, or one of many reasons why planes fly. And let's look at how Bernoulli is spelled. It's Bernoulli. Bernoulli was a scientist, and he's the one who came up with understanding how Bernoulli's principle works. So one of the things you need to understand is air is little particles all over. And air is a liquid. Now, I know that you've talked about in the past, in previous grades, the states of matter. So the states of matter include gases, liquids, and solids. So both gas and liquids are actually fluid. And what that means is that they fill the space that they are in. So you can imagine an ice cube, that's a solid. When you take the ice cube out of the refrigerator, out of the freezer, and you put it down, it stays in the same space. If you have water and you take it out of the cup and put it on the counter, it tries to fill the space. It makes a big mess, right? So a liquid is going to spread and try and take up as much space as it can. It spreads itself out. It won't stay in a pile because it wants to take up as much space as possible. And a gas is going to fill the space not just as forced by gravity, but it is going to fill the space as it moves upwards and outwards. So both liquids and gases are fluid. And so the air that we have is a fluid, and it tries and fills as much space as possible. So if I was to put a handful of air into an empty space where there's no air, also called a vacuum, those particles of air are going to try and spread out as much as possible. So I want you to kind of think of a pile of people in a classroom. Let's try and get it so you can see what I'm drawing. A pile of people in a classroom, and you stick them all in desks together. What they would want to do is spread themselves out, right? And gases are like that. They want to spread themselves apart as much as possible and take up as much space. So the molecules that are in air are spread out. Now, there's a couple of things you need to understand about that. When air is warm, it spreads out more. So just think about how we feel when we're really hot. We don't want lots of things tight around us. When air is cold, it stays close together. It stays closer together. And the proper word for that is dense. It is denser. We also need to know that when air moves fast, it is less dense. And when air moves slower, it is more dense. So let's summarize that. Air that is warm is going to stretch itself out further. Air that is cold is going to be denser. Air that's moving fast is actually less dense than air that is moving slow. So I'm going to show you this with an elastic, if I can find one in my drawer. Here I've got an elastic. So you can see that I'm taking the elastic and the top is stretched just as much as the bottom is. So I'm going to hold it like this. So you know that there's this much elastic on the bottom and there's this much elastic on the top. So if you were to weigh it, this would have the same weight as this would have. Now, if I take this elastic and stretch it, there is far more distance on the top than there is on the bottom. The molecules or the cells, the atoms that are holding this elastic together are more stretched out right now on the top than they are in the bottom. Okay. So if you apply this to a plane or an airplane's wing, this is getting my hand all dirty. A wing of an airplane looks like this. Okay, so this is the front, and this is the back of the wing. So air is coming along as the engine is moving forward. There's thrust pushing the engine against the air. And the air is moving, some of it is moving under the wing, and some of it is moving over the wing. And these molecules of air that are moving over the wing want to, for whatever reason, get to point B at the back at the same time. So this is going to travel a short distance. This is going to travel a far distance. So if you had, let's say, 3 air molecules, we're just going to use a really small number, and it's traveling from the front to the back, it's going to be spread out like that. But the 3 air molecules up here have a greater distance to travel. They are more spread out. And so it is having to move faster to get across the top of the wing than it is to the bottom. Because these air molecules are moving faster over the top of the wing, and the air molecules in the bottom are moving relatively slower than the top, this has less pressure because they are moving fast. And this has higher pressure because they are moving slower. So you've got a low pressure system up here and you've got a high pressure system here. Now let's go back to those kids in the classroom. If you were all scrunched together really close, what would you want to do? You would want to move outwards, right? Well, these high pressure, it wants to push upwards to get to the lower pressure area. So it is pushing the wing upwards. Brilliant concept. So Bernoulli discovered that, And so we know that where there is low pressure, things are going to move towards it. We can think about this with weather. Remember grade 5 when you learned weather patterns? And you talked about low pressure system and high pressure system. And so in our atmosphere, some of the air has got lower pressure, and higher pressure systems try and push into those. So sometimes you've seen banks of clouds in the sky as a high pressure system is moving in. And it also accompanies by a lot of wind, because the air from the higher pressure system is trying to move forward and move into the low pressure system. It's the same concept that allows us to have flight. So the air that's moving over the top of a wing of a plane is moving faster, and the bottom of the plane is moving slower. High pressure up here, low pressure down there. This shape is called an airfoil. Airfoil.